Okay, so in the last video we were talking about this projectile motion problem and we'd gotten down to part D. Let me just remind you of what the function was. Right here, negative 16t squared plus 70t plus 5. This is the ball thrown vertically upward with initial velocity 70 feet per second and height 5. Okay, so when will the ball hit the ground? Well, note that when the ball hits the ground, that's going to correspond to this point right here, which is height 0, right? So it's a 0. Basically, it's just a 0 of the function. So not 0, but a 0 of the function. So you're going to have, actually there's another one that's over here kind of off of the calculator, but that's before the domain actually began, because we don't begin the domain until right here, so we only care about this 0 over here. So we're going to go to second calc 0, and I want to choose a left bound that's sort of close to that 0. That looks pretty good. And then for a right bound, whoa. Okay, so for a right bound, that will do. And my guess is right there. So there you go. There's my 0. That says negative e 1e negative 11, which is a scientific notation for a very, very, very close to 0 number. So that is 0, and our x value is 4.45. So after 4.45 seconds, the model's application, domain, and range. Well, we just we just found the range, and I'm sorry, we just found the domain. The domain will be from 0 up to 4.45. And the range is going to be from 0, because we do go to 0, up to the y-coordinate of the maximum, which we found that already, I believe. So that's the y-coordinate of the vertex. Okay. So, yeah, so the y-coordinate of the vertex is 81.56. All right, so that's a little example about projectile motion. Let's take a look at another one. The Grand Canyon Skywalk allows tourists to stand on a glass platform and view the canyon floor 2,000 feet below. If a boy drops a ball over the side, about how long will it take to hit the ground? All right, if he drops the ball, then his model for the height of the ball at time t, by the way, you should not do this, but if you did, your model would be negative 16t squared. Your initial velocity is 0, because you didn't actually throw it, you just dropped it. So 0t would be the next term. So you can just not write that because it's 0, and your initial height is 2,000. So it's actually, the full model is just this, negative 16t squared plus 2,000. And so to find when how long it will take to hit the ground, basically this is what you have. So we want to find that 0 right there. So again, we would use calc 0. All right, let's do it. All right, so off camera, I went ahead and entered the function. And then to graph this function, what I did was I went to the table, and I want to see how long it takes me to get to 0. And I see that happens between 11 and 12 seconds. So then I set my window to 0 to 15 and did zoom fit and got this picture. Okay. And now I can actually find that 0, which is right here. Left bound, right bound, and guess. So 11.18 seconds. Okay, what about part B? If instead he throws the ball down, so now he's mad at 25 feet per second, how long will it take to hit the ground? All right, so for this part, our model is going to change. It's going to be negative 16t squared, minus 25t plus 2000. Now it's minus because I'm throwing the ball down. So that's a negative initial velocity. Be careful about that. Remember to pay attention to that and act accordingly. So this would be the function. We'd enter negative 16t squared minus 25t plus 2000. And then we basically do the same thing. We want to graph it and find the 0. So I don't think I need to run through that process again since we just did it. Sorry about that. So basically we will just do calc 0 once again, and you should find that the 0 for your new function is 10.43 seconds. So, initially it was 11.18, but if you throw it down, then you can get there at about 3/4 of a second faster. All right, so that's some problems about projectile motion, and I believe this is the end of section 6.1. Yes, it is. Okay, so we will end the video here.